Okay, in this video, I'm going to be talking about mega scale rivers and their correlated features. I want you guys to have a clear understanding of river terraces and river widths. And I'm going to explain to you guys how these rivers had to have been extremely wide at a certain point in time to make these clear and distinct riverbanks. So let's start off with in the Midwest, right by the James River. It used to be 70 miles wide, according to these riverbanks, not according to me. And using topographical maps, we can go right over and find that not too far from it, there were massive ripples and mound formations. So you got a 70-mile wide river, and then you've got ripples over 1 mile wide, or in wavelength rather, in Nebraska. So you got correlating features. Now, this is the case for everywhere. You go to Saudi Arabia, you've got ripples, drumlins, sediment lobes, and of course, massive river beds, river terraces, river banks, whatever you want to call it. What you're looking at right now is a river bank. So when we go to topographical map, we can see from bank to bank, 43 miles wide. That's what you're seeing right there in the middle of the screen. That gives us massive insight when we look at all of those features north of there that I showed you previously, and we can see how they're mounds. We can see how they're correlated with drumlins, sediment lobes, ripples, riverbeds, all sorts of things. Okay, now let's go by the Salton Sea. We got wide riverbanks. We've got expansion bars. Of course, we've also got the mounds and the ripples that are over 1 mile wide again, and accretion ridges with ripples on them parallel to the Salton Sea, which is a scour from a water current that ran across from LA down to the Gulf of Mexico. Okay, this is the accretion ridge that's covered in ripples that are almost 1 mile in wavelength. So there's so many features that correlate with one another, and they have got nothing to do with altitude or latitude or anything like that. We find them in Russia, right? So now let's check it out with topographical map. Now we can really see what's going on. 30-mile wide river that had an expansion bar, had a fluvial fan deposit. But what's really cool is we get this streamlined formation right here. See how that's streamlined from a water current, well, really from an ocean current sweeping across there? That's really given us insight on how these features formed, and these lakes are actually a type of scour. They've got nothing to do with, people think they're the Carolina Bays. They got something to do with ice projectiles. No, they're a type of river scour. We go to Ethiopia. We see evidence of massive river channels that came across from a sweeping ocean current. Extremely wide river channels, a lot of current ruts. I mean, it really looks like Washington and Oregon right there. But this is something we find all over the world, and of course, they're correlated with salt pans. But yeah, I'm just giving you guys the tools so that you can see. You go to topographical map and you can understand a topographical map. You can understand satellite imagery, Google Earth imagery, and you can even get places to look at to see the rivers. For example, when Egypt is incredibly dry, there's not even a river there. But from the terraces, we see that it was once 21 miles wide, which is wider than the Nile, even though there isn't a river there now. This spot actually reminds me of the Salton Sea, that little scour to the right. You can kind of see the path where the drumlins curve to the right, and then you get the scour. And then we go topographical, and then we see that Europe is absolutely full of mega scale rivers, or the remnants of these mega scale rivers, rather. I'm sorry, this is kind of a quick video, but I just want to get you guys an idea of what's going on when we find 46-mile wide rivers all over Europe. You know, it's telling us something important. And it doesn't have anything to do with an ice sheet, because we also find the same thing in Africa. And I'm going to show you guys Africa in a little bit. Okay, this is Russia. Nice wide rivers. And now let's go to Africa. And now we can understand these drumlins that show a current these drumlins were parallel with the current that poured off of the west coast of Africa. Northwest Africa is too obvious. Okay. Topographically, we can see the same thing. We can see these drumlins. We can see the mound formations. And we can understand the river width of this sheet water flow. Okay. The ripples are perpendicular to the current. The drumlins are parallel to the current. That's how simple it is. And then you kind of get streamlined formations as well. Clear ripples. This is North Africa. We get some expansion bars. Expansion bars happen when a current has the ability to expand due to the terrain. And of course, also in North Africa, lots of drumlins showing how the current actually curved. You can see exactly how the current curved. This is exact evidence of sheet water flow. Gets a little bit complicated. When it gets complicated, that's when you get mounds. Perfect example of mounds in North Africa, Sudan, Algeria. All these spots are great for. Just go to Google Earth, go to Sudan, go to Algeria, and you'll see these spots and you understand them. And especially West Africa. I mean, West Africa, Chad. Just take a look at that and you'll see what happened. All these ripples are over a mile in wavelength, so we know it's not any sort of rainfall event. It's the ocean, right? It was the ocean that did all of this. Just based upon the scale of it, we can see these nice drumlins. And also, of course, the salt scablands also indicate that it was all to do with the ocean. So that's North Africa. You can see the paths of ripples, the drumlins, all that. So thanks for watching. I got more videos coming soon, and my videos are just going to get better and better. I know they're kind of shitty right now, but I'm going to work on my quality. I'm just trying to get the content out there. So I appreciate all you guys supporting the channel, and I'll see you guys in the next video. Okay, bye.